You want to hit the light? All right. So we're going to plug it in. And we're going to get negative 2 cubed plus 5 times negative 2 squared plus 2 times negative 2 minus 8. And so we get negative 8 plus 20. Okay, minus 4 minus 8. So you get negative, ooh, boom, 0. What does that mean? What's 0? It's a factor because what's 0?
Because the remainder is 0.
Paying attention. This is wonderful. So this would actually be a point, which what's the coordinate at? You were right. What would be the coordinate? Thank you. Negative 2, 0. So it is actually also a x-intercept. Boom, moving into this. Okay. So we know now that that's a factor, correct? So up until now, all we've been able to do is it's a factor or it's not. That's all we've been able to say, or what the remainder is, correct? But we haven't been able to factor anything. And I told you that in polynomials that I would teach you how to be able to factor x cubes and x4 and x5, right? Up until now, we've only been able to linear in grade 10 and quadratic in grade 11. Now we're going to be able to move on. What we need, though, in order to factor is we need a factor that works. So what we're going to do, and we're going to pay attention. We're not going to use remainder theorem. We are going to factor. Are we watching? Because this is where I lose people. This is how we factor. It's called synthetic division. It's really easy, actually. Oh, my. Yep. Okay. So if x minus 2 is a factor, what we're going to do is we're going to use the x-intercept, okay, for our synthetic division. So we're going to put x equals 2. And we're going to put this. Now pay attention. Nope. X equals 2. So we are going to do this. Now pay attention. When you make the L, you need to make the L a deep L. Because you need to have a row of numbers here and a row of numbers here. So what annoyed me was I think I was writing in pen in grade 12 at the time. And my teacher did not tell me that. And then I had to then I had to do this, and then I had this line, and it was just quite a debacle. Then I had to get out whiteout, and you don't understand because you have whiteout that you just roll and it's dry. No, I had to. All right. So we have the 2. Now what we're going to do is we're going to make sure we can count down. Now can we? 3, 2, 1, and then that one be to 0, correct? If we can count down, we're good. If we can't count down, we have to put a 0 in for a placeholder. So say you were missing the x squared term, you just have to put a 0 in for it. Because you'd have a 0x squared technically, right? Because it doesn't exist. Okay? Bear with me. So we're going to put the coefficients. The coefficients are the numbers in front. So what's in front of this one? A 1, a -6, a 3, and a 10. And that's going to go along the top. 1, -6, 3, 10. Okay? Our first step is going to be to drop down the number, and then we're going to multiply, add, multiply, add, multiply, add, multiply, add till we're done. It's consistently the same thing. Yes, you will see. So drop down the 1. First step. Okay? Yes. Yes. Yep, because you're going to still have numbers beside that. Do what I do. Okay? Drop down the 1. Then you multiply. 2 times 1 is? 2. And then you add. We multiply, bring it up. And then we add. 2 times 1 is, and then you write it here. Follow, because that's how you do the. Okay, but we're not done yet, guys. Just add now, please. Stop the madness. It's really not that bad. You need to just chill. Okay. 2 times 1 is 2. Then you add these 2 numbers. -6 plus 2. This has never been this hard. Not in 11 years. -6 plus 2 is? negative 4. So we multiplied, we added, and then we just continue to do that over and over. Multiply. 2 times negative 4 is negative 8, and then we add. You know what? I think this has happened in 11 years. Just they were quiet and feverishly freaking out in their heads, but you guys are just verbal, and that's where we were at. 3 plus negative 8 is? Now we added, so now we're going to multiply. 2 times negative 5 is? And then we add, which is? And then you box that back. Yeah, we do. Okay, you box that back number. That back number is what do you think, possibly? It's a 0, first off, because it is. What do you think it represents? No. The remainder, yes. The other, no. So this is the remainder. Okay? So do you have to do remainder theorem to get the remainder? No. Remainder theorem is extremely important for the 2 quiz questions we did, though. So if I was missing a k or I was missing an m and an n, you can't do synthetic division with m and an n to solve it. Okay? So you need remainder theorem for these questions. But remainder theorem you can use to just find remainder. That's all it gives me. Okay? Synthetic division is going to let me get with the factors. So this is x equals 2. What was my factor? X minus 2. Okay, we're not done. We have a factor, and then we have some random numbers at the bottom of an L. Correct? The random numbers at the bottom of an L actually represent something. They're not just random numbers at the bottom of an L. So we took out a factor of x minus 2 out of a polynomial that was x cubed. Do we agree? So it's going to go from x cubed to x squared. So this is just a quadratic left over. It's always 1 less than this. So if this is an x cubed, this is actually going to be 1x squared minus 4x minus 5. What do you suppose we're going to have to do with that? Factor. Factoring is back. So x minus is good. X minus 2, and then that technically is really what we're sitting with for the polynomial currently, right? We're breaking this polynomial down is what we're doing. We agree? So what have we not broken down yet? X squared minus 4x minus 5. So off to the side, I'm going to do x squared minus 4x minus 5. If your factoring is not as good as it could be, if you have no idea what factoring is, I don't know how you got here. But if you don't, if you've never heard the word before, you're like, what is that? Maybe you were in French class. I don't know. But if you don't know how, the worst thing you can do is flounder and not figure it out. The best thing you can do is admittance. Come to me at lunch and be like, you know, Lepp, I have no idea what factoring is. It is. So how are we going to do this? We are going to go what times what equals, and I'm not going to do this over and over, so I'm not going to go slow-mo for life. So if you have no idea, please come in. What times what equals 1 times negative 5? A times c. So negative 5. And then what plus what equals the middle? Negative 4. Yeah, it's coming back. Negative 5 and 1. Do we have to do decomposition when there's a 1 in front of the x squared? No, that's silly. And you're like, let's decomp. That scares me too. So we are going to go x and x. We can go right up to x's into brackets if there's a 1 in front of your x squared. We agree? And then minus 5 plus 1. Because those are my factors. We agree? So this lovely ditty of a quadratic broke down to x minus 5 and x plus 1, did it not? And then this little lady stayed in front. Little lady here, she stayed in front. Okay? So how many factors are there in this polynomial? 3. At maximum, you'll have the number of exponents. So if the exponent on the polynomial is x cubed, you'll have at max 3 factors, which means you'll have at max 3 x-intercepts as well, right? Because what are these factors? 1 step away from x-intercepts. You're right, 1 step away, because that's not an actual x-intercept yet, is it? So what would the x-intercepts be? So we'd have 2, 0, 5, 0, negative 1, 0. We agree? At maximum, we will have 3 because it's an x cubed. We agree? Okay. Let's try it again. I feel the freak out zone may reduce. So here's the steps to how to do synthetic division for you on the next page. If you don't have them copied down, you probably won't need them. If you do want to copy them down, you can copy them down after. All right. So the first thing we need to do, though, is find possible x-intercepts, okay? Because we need an x-intercept. We need an x-intercept to start the synthetic division deal going, right? We needed one. The potential x-intercepts are zeros. Zeros, x-intercepts, roots, all mean the same thing. Zeros, x-intercepts, roots, okay? All mean the same thing. We agree? Now, we need to identify possible ones. The possible ones come from back here. So if this is a 6, our potential x-intercepts or zeros are plus or minus the factors of that back number. They're always plus or minus the factors of the constant. So on a question, it could just say, what are the possible x-intercepts? And your answers could all be 1, 3, and 6. And they might, none of those 3 might be actual x-intercepts. But I didn't say what is the x-intercepts. I said what are the possible x-intercepts. So you have to remember the possible ones are the factors of the back. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So your possible factors, x-intercepts, are the positive, negative factors of the constant. The constant is the one without a variable. Okay? So how would we figure out which one worked? We could use remainder theorem, plug each one of them in until you get what? A 0. Or 2, you could do synthetic division with every single one until you get a 0 in the box. That could take quite some time, right? Especially if like it's 24 at the back. Like plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. You have to try them out till you get a 0, right? You luckily have your calculators in front of you. So go to your y equals and type it in. Type in this cubic function. It's called a cubic function because it's cubed. It's a degree 3. So in your y equals, you're going to have x cubed plus 2x squared minus 5x minus 6. I didn't hear it. Oh. Awesome. Okay, so positivity. Be kind. Okay, so y equals x cubed plus 2x squared minus 5x minus 6. We have that in our y equals, right? Then if we go second graph, what does that take us to? Second graph? The table thing. So the table gives us what? Coordinates. What do we need? We need x-intercepts. X-intercepts are when what? Close. Y equals 0. So we need to find one. So what's one of them? Plus 2? Okay. So they could all be on there, correct? What they'll do often is pick a cubic function where you can't have all 3 on there. Or they'll pick it so that you have some variables in it so that you can't just go to your table values and take them off. Okay? They write proper questions. So make sure you can actually do it. So x equals 2 is the x-intercept. We agree? So what I'm going to write above it is x minus 2, so I also have the factor. This question says factor. So do I actually care what the x-intercepts are? No. Factors are those things in brackets. So ultimately, in the end, my answer is going to be bracket, bracket, bracket. I'm not going to keep going, right? Because it doesn't say solve. If it says solve, solve means tell me what the variable equals. Does it say solve up here? No, so I'm going to stop when I get to factors. Okay, so what do? I write down the coefficients, but I make sure I can count down first. So I have 3, 2, 1, 0. Do I have everything? Yes, I don't need placeholders. So I'm just going to put the numbers in. 1, 2, -5, -6. We agree? Bless you. It's a weird way of doing it, but I like it. Okay, so we drop the 1 down, and then what do? Multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. So I'm done, which is way more than I'm going to need. Okay, so 2 times 1 is 2. Add. 2 plus 2 is 4. Multiply. 2 times 4 is 8. Add. Negative 5 plus 8 is 3. Multiply. 3 times 2 is? And we are happy because this is a, what if it wasn't a 0? 2 things could have happened. You could have taken the y-intercept, which some people do. They grab the y-intercept off the table by accident. Or they flip the sign and use the factor by accident. Or you just messed up your synthetic division. Okay? So make sure you check, before you go like freaking out, check and see that you actually did that right. Okay, so we have one factor. Our one factor is x minus 2. And then currently this is our other factor. It just doesn't have any variables. So to put the variables back in. We were x cubed, so this is going to be x squared minus 4x plus 3. We agree? So once again, we're not going to have to do decomp because we don't have anything but a 1 in front of the x squared. So we have 1x squared minus 4x plus 3. So I say what times what equals a times c, because this is a, b, and c in a quadratic. 1 times 3, so 3. And what plus what equals negative 4. You take your signs with it. So what multiplies to give you positive 3 and adds to give you negative 4? Negative 3 and negative 1. So we have x minus 3 and x minus 1. So up here I'm going to have x plus 2, x minus 3, and x minus 1. Now this is just another way of writing that polynomial. That polynomial up here was x cubed plus 2x squared minus 5x minus 6. Was it not? Oh, I don't know why I wrote plus. Sorry. X minus. So if this polynomial up here was actually p of x equals that polynomial, right? This is just another way of writing it. P of x would equal x minus 2, x minus 3, x minus 1. If I expanded this all back and collected like terms, what would I get? The original polynomial, right? Oh, guys, this is really bad. What's this up here? A what? A positive 4. What did I write? Boom, 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 boom. Just a whole bunch of... Ah! Sorry. This has been really good. This question is solid. Anyone learning off of this one is going to be golden because I just put a whole bunch of random negatives in wrong spots. Super awesome. Okay, let's try another one so that this is not the only one we're basing our lives on because that would be sad. Okay. All right. So we're going to look at B here first, please. Why would I pull you to B? No. Why would I pull you to B? Placeholders. What are we missing? Okay. So we're going to go x cubed minus or plus, it doesn't matter, 0x squared minus 27x plus 10. So that we remember to put that placeholder for our synthetic division. What are the possible zeros of this function? 1, 2, 5, and 10. Factors of your constant. Yep. So plug it in your calculator, and what do we have to look for? When y equals 0. Or we could test 1, negative 1, 2, negative 2, 5, negative 5, and 10, negative 10, and see which one gets me a remainder of 0. These are all options. So you can use your calculator, or you could check doing remainder theorem. not into your calculator. You only need that 0x squared for your synthetic division. So which one works? So we're going to say x equals 5, which means my factor is x minus 5. You agree? Then we put in our numbers. 1, 0, negative 27, 10. All right. Drop the 1. 1 times 5 is what? Then we add. 0 plus 5 is 5. 5 times 5 is? Negative 27 plus 25 is? And then negative 5 and negative 2 is negative 10, which makes us happy because the box becomes 0, and we need it to be 0. So we have x minus 5 as our one factor. And then this one's going to be x squared plus 5x minus 2. You always start one less. So if this is x cubed, this is x squared. Then we go off to the side and factor it. Can we factor it? What multiplies to give me negative 2 and adds to give me 5? No. It can't factor. There's nothing you can factor. Nothing multiplies to give you negative 2 and adds to give you 5, is there? So this is a really awesome question when it says factor, because you're done. If you can't factor it, you're done. However, it's a really not great question when I ask you to solve, because you can't factor it. So that means you have to use quadratic formula to get the x-intercepts. Okay? So if I say factor, we're done. This is a great question. Okay, I can't factor it. So that's as good as it gets. But if it said solve, I would get x equals 5, and then I'd get the quadratic formula for those ones. I would assume so. All right. Now, the problem is I put a factoring question on the test, and you guys will break that down with the quadratic formula. You're doing more work. More work is always better. If I ask you for factors, give me factors. Don't give me roots. Don't give me zeros. Don't give me x-intercepts. Okay? So don't keep going, is my point. So we're going to look at C. C is going to get you some decomp. So let's potential zeros, or x-intercepts, will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay? How do we get which one it is? Plug it into your calculator. It brought a lot of joy right there. So which one works? 3? Now sometimes there's more than one. Is it going to matter which one you pick? No, you'll just be factoring a different factor on the bottom. That's all. So x equals 3. So we have x minus 3. It's our factor. Can we count down? 3, 2, 1, 0? Yep. So we don't need placeholders. 2, negative 1, negative 13, negative 6. The moment in front of your leading coefficient you don't have a 1, you're going to have to do decomp. Why is that? Because what's the first number I'm bringing down? 2, not a 1 anymore. Okay. 2 times 3 is 6. Add. Negative 1 and 6 is 5. Multiply. 15. Add. 2. Multiply. 6. Add. 0. So right now I have x minus 3 and then 1 less. 2x squared plus 5x plus 2. And then off to the side I'm going to factor that. So you say what times what equals 2 times 2, which is 4. And you keep the sign. So if one of them was negative, it'd be negative 4, right? And then what plus what gets you the middle term? Positive 5. So what's it going to be? 4 and 1. Now, I can't just go x plus 4, x plus 1 anymore because there's not a 1 in front. What I'm going to do for decomposition is you keep those two terms. You keep the 2x squared and you keep the 2. Bless you. And we're going to replace the middle term with 4x plus 1x. Why can we replace the middle term with 4x plus 1x? Because it's 5x just bigger, right? Just more terms. That's all it is. So decomp literally is I break the middle term up into 2 terms, and then I have 4 terms now, and I do grouping from grade 10. That's all decomp is. Okay? So we keep this first term, 2x squared. Then the 5x gets replaced with plus 4x plus 1x, and then I keep the plus 2 at the back. So really, all I've done is replace the middle term. You see what I'm doing? And then you group the first 2, and you group the back 2. So does it matter if I go 4x plus 1x or if I go 1x plus 4x? No, sometimes it's easier depending on which way you put them, but you're still going to get the same thing. Okay? So I say to myself, what can I take out of 2x squared plus 4x? And an x. So I take out a 2x, and I'm left with x plus 2. Great. Now, out of the next bracket, I need to take something out that I'm left with x plus 2 in the bracket, because I need the brackets to match. So all I can take out is a 1, right? A plus 1. So I take out a plus 1, and I'm left with x plus 2. Now, really, I only have 2 terms here. Why do I only have 2 terms? Because terms are attached by plus or minus signs. We agree? So this is one term, and this is another term. We agree? They're attached by plus sign. What do they both share in common? So I take the x plus 2 out. And what's left over when I take that GCF out? 2x plus 1. And that's decomp. So we have x minus 3, x plus 2, 2x plus 1. Make sense? Okay, so what I'm going to have you guys do is only degree 3s today. Tomorrow we do degree 4 and 5. The more degrees you add, the more synthetic divisions you have to do. Because when you do a synthetic division, what happens? It drops it down by 1, correct? So if I had an x4 and I had put my x4, what would be below it now? An x3. And how do I factor x3s? With synthetic division. So I'd have to do another synthetic division. So all you're doing is more synthetic divisions, right? But you're still doing the exact same steps. It's not a big deal. So you do your x4, get your root, fill it in, and then you do the x3. It's the hiccups are like, so page 133. Don't know why, just another number sign. Felt like it. Enjoy. So tomorrow,